Okay, so for the review, the first lesson that we did was talking about multiplication with fractions. But this was just working with unit fractions. And what you need to remember the most about a unit fraction is that it has a 1 as the numerator, meaning 1/8 is a unit fraction, 1/4 is a unit fraction, 1/6 is a unit fraction. That's what we have to deal with. So if I'm looking at this, I see 1/8 here. Those are my unit fractions. How many 1/8 are there? 5. Another way of saying it is there is 1/8 5 times, which would be this multiplication sentence, 1/8 times 5. When you're multiplying, all you do is you keep that denominator in its place, and you are doing 1 times 5. That's it. That's it. That's all you're doing. So when I'm being asked to fill out this, it says write a multiplication equation with a unit fraction that describes the fraction shown. Okay, well first I need to figure out what my denominator is. How many spots are there? 1, 2, 3, 4, 5, 6. So it is out of 6. How many are shaded? 4. So this is showing me 4/6. Now, it's wanting me to do unit fraction. So what would the unit fraction be? What would each one of these be? Each one of these would be 1/6. How am I getting 1/6 to become a 4/6? Multiplying it by 4. That's it. So 1/6 times 4 equals 4/6. Okay, for 1/4 and 1/4, how many times is 1/4 there? It's 2 times. So 1/4 times 2 equals 2/4.
Can you simplify that?
You can simplify it as long as you have the original, because you need to show that you understand the denominators stay the same. And then yes, it can be reduced, but you'll notice that questions will say simplify it afterwards. So as long as you read the questions and pay attention to that, you should be fine. Okay, now it wants me to fill in this. Find each of the missing values. 4/5 equals what times what over what? I can tell 5 is my denominator. 5 stays put. So that's a 5. For this to become a 4, what would I have to be multiplying?
1 times 1.
I mean, I'm talking about unit fractions here. So this is 1/5 times 4 equals 4/5. So same over here. I know there's a 1 here because I'm working with unit fractions. What's my denominator? 12, because it never changes. So how did this 1 turn into a 7?
Times 7.
Times 7. That's it. No problem. Now, if you move on down, you'll notice that the next part is asking you to multiply non-unit fractions. It's showing here 3/5. How many times do you see 3/5?
Twice.
2 times. So 3/5 times 2. If you notice down here how they've got it laid out, 2 times 3/5 can be the same as 2 times 3 over 5, which is 6/5. 6/5 is an improper fraction and will never be taken as an answer. So it would be 1 and 1/5. So if I'm looking over here, what fraction am I dealing with? 3/10. And how many times do I see 3/10?
3 times.
3 times. So really it's not 3 times 3/10. I'm going to rewrite it as 3 times 3 over 10, which is 9/10. Okay, down here in this picture, what does each fraction show me? It's showing me 2/3. And how many times am I seeing 2/3? 4 times. So really I'm going to rewrite it. Instead of 4 times 2/3, I'm going to write 4 times 2 over 3, which is
830.
super duper improper. Got to fix it. How many times can 3 go into 8?
Twice.
Twice, because 3 times 2 is 6. 8 minus 6 is, gave you the answer, 2/3. So 2 2/3 is my answer. Last problem here, the word problem. Adrian uses 3/4 cup of milk in each bowl of cereal he eats. He eats 1 bowl of cereal each day. How many cups of milk does Adrian use for cereal in 1 week? Okay, so how much of a cup am I using? 3/4. And how many times am I using it? 7 times. So I'm going to rewrite that. 7 times 3 over 4, which is 21/4. Okay, now I got to reproperize that. 4 can go into 21 how many times? Because 5 times 4 is 20. 21 minus 20 is?
1.
So 5 1/4 is my answer. Okay? So good so far? Okay, so let's move on to the next page. All right, so now this time we are looking at converting fractions to decimals, mainly just figuring out reading this to make a decimal. If I ever see a bunch of squares, what does that mean? Out of 100. If I ever see just a bunch of long lines, what does that mean? Out of 10. So if I'm looking here, how many of these are filled in? 1, 2, 3. 3 out of the 10 are filled in. So 0.3 have been filled in. Okay, how many of these have been filled in? 6 out of 10 have been filled in, meaning 0.6 have been filled in. Okay, now they're changing. How many of these have been filled in? 21 out of 100. I'm still writing it as 0.21. What about here?
35.
Okay, out of 35 out of 100, 0.35. What about this guy? This is 1 whole. The whole thing's been filled in. Now, how many over here have? 1 3/10, which also equals 1.3. Good. All right, moving on to the next bit. Fun with number lines. So, whenever I'm looking at a number line, it's best to understand when it's talking about my denominator, that's how many little marks there will be. So from 6, 1, 2, 3, 4, because technically this would be 4/4, I know that my denominator is going to be a 4.
Yeah.
Same thing goes with decimals. 0.0, that's 7. 8.0, that's 8. 7.1, 7.2, 7.3. I can use the position of those to help find where I need to go. So right here, it says name the fraction at each point. Well, so let me notice here. 3, 2, 6. 3, 3, 6. So what do you think G is going to be?
3, 4, 6.
3 and 4, 6. What's H going to be?
3, 5, 6.
3 and 5, 6. What's F going to be?
3 and 1, 6.
3 and 1, 6. So down here I can fill it in because I already did all the work. G is 3 and 4, 6. F is 3 and 1/6. And H is 3 and 5/6. Okay, now look, I've got decimals instead of fractions. Name the decimal at each point. Well, if this is 540 and this is 545, What do you think each little mark in here is representing?
5, 1.
0.01. So this is 5.40. So this would be 5.41, 5.42, 5.43, 5.44, 5.45. So with that in mind, what's K?
5.47.
5.47. What's M? That's an easy one.
5.55.
It's literally labeled for you.
Thank you.
It wasn't me.
Math spirit.
Thank you, math spirits. 0 or O. What's O?
5.68.
5.68. Okay, now it wants me to go back to this number line and find what these points would be. Okay, now hang on. Whenever I'm dealing with decimals and number line stuff, I can only have two denominators. One denominator is a what? In decimals, what are the only two denominators that I can have? 10 and 100. So if I am going to convert this into something like this, I have to change it. So 5 3/5. What do I have to do?
5 6/10.
5 6/10. Exactly. I have to get this denominator into a 10. So 5 6/10 would then become what decimal? 5.6. So what point on here is 5.6?
Oh.
N. So number 7 is N. Okay, for 5 1/2, what would I do to 5 1/2?
Oh, you would change the 2 to a 10.
Change the 2 to a 10. If the 2 gets changed to a 10, what does the 1 get changed to?
5.
5 1/2 becomes 5 5/10, which then becomes 5.5. So what letter is that?
L.
L. Then, oh, that's nice. 5.42, where's that? What is that?
J.
J. Good. Okay, moving on. Now we're kind of doing that same business that we were doing before, where we're changing those decimals. It wants me right here, it says write 6/15 as a decimal. Well, 6/15, 15 can't go into a 10. It's too high. 15 can't be turned into 100. So, you know what? Sometimes you have to go backwards before you can go forwards. So 6/15 needs to be reduced to its simplest form, which in this case is 2/5. Because 6 and 15 both have a factor of 3. Now that I've got 2/5, I now have to re-multiply by a new number to get it to be a denominator of 10. They did it times 2, which makes it 4/10, which then makes it 0.4. So now we have to do that here for 3/6. For 3/6 to become a decimal, all right, what do I need to do?
Times 2.
3/6. Can I get 6 to turn into a 10? No. Can I get 6 to turn into a 100? No. What do I do? Sometimes you have to go backwards.
Into a 2.
Okay, so if I turn my 6 into a 2, what does the 3 turn into?
1.
Okay, because I divided by 3. So 3/6 becomes 1/3. Correct? Nope. 1/2. Now, what can I do?
You change the 2 to a 10.
Okay, I'm going to multiply by 5 on both sides. So 1/2 becomes 5/10, which now becomes 0.5. Okay, for the next one, for 1/25, that's a nicer one. Can 25 turn into 100?
Yes.
Yes, because what am I thinking of?
Money.
I'm thinking of those quarters. 25. Well, how many quarters do I need to make a dollar?
4.
4. So if I multiply by 4, that means I'm going to have 4 100ths, which in decimal would be 0.04. 3/50ths. It's another nice one. Can I make 50 into 100?
Yep.
Yep, just got to double it. So 3 becomes a 6, 50 becomes a 100, and that becomes 0.06 because it's out of 100. Okay, 9/12.
You can make that to a 2.
Can I turn 12 into a 10? No. Can I turn it to 100?
No.
No. So I got to go backwards. What factor do they both share?
2.
2? I can divide 9 by 2?
3.
3. 9 divided by 3 is 3. 12 divided by 3 is 4. Well, there's that 4. I go back up to here and think of those quarters times 25. 4 times 25 is 100. 3 times 25, just think of 3 quarters, 75. So that becomes 0.75. Okay, 2/10. That's nice.
Yeah.
0.2.
Thank you.
19/50ths.
Double it.
Double it. So double 50 is 100. What's double 19?
38. So 0.38.
0.38. The only time you ever begin with a 0 is when you have a one-digit number over 100. And it's the only time you would be doing that. Okay. This is some fun stuff. It's more tedious, but it's important. This is expanded form. Word form and expanded form.
Really?
Yup. So, 12. The reason it wants you to do this is to understand that 10th and 100th are not 10 and 100. That's the main part. So if I'm going to write this, this is 12 and 13 hundredths, right? So you would write 12 and 13 hundredths. You have to write a little small. The next part is asking you to expand on it. Expanded form is taking every single part and making it by itself. So 12 becomes 10 plus 2 plus 0.1 plus 0.03. Okay? That's the expanded form of that. And you know what? I'm going to write this on another piece of paper so you can see better. The next one it's asking you to do is 1.09. 1.09 in word form would be 1 and 9 hundredths. That's the important part to know, is the hundredths. In expanded form, it would just be 1 plus 0.09. That's a nice one. Okay, 11.1. How would I write that?
11 and 100.
Nope.
10. 11 and 110.
11 and 1/10. The only time you will ever write a tenth, the word tenth, is when you have something like this, when it's just point and then a number. To write this out, I would do 10 plus 1 plus 0.1. That's it. 88.08. Okay, in word form, 80, 8, and 8 hundredths. In expanded form, it is 80 plus 8 plus 0.08. All right, moving on more. Comparing. These are nice, but we still approach every problem with the same work ethic. It does not matter if it's easier than others. It does not matter if it is more challenging than others. You still approach it by looking at what it's asking you to do and solving it and checking over afterwards. When I have things like this, all I have to do is go from the beginning and check each place value. If I'm comparing 1.82 and 1.91, okay, so 1, 1, those are the same. 8, 9, 9 is bigger. 1, 1, those are the same. 1, 1, those are the same. 0, there's no 0 here, but what do I know about this? It equals 10. So they are equal. Order the numbers from greatest to least. This is where you get in the most trouble because you assume it is going to be least to greatest. Or you assume it's going to be the opposite of what it is asking you. And then it is incorrect because it's not in the right order. That's where you got to really be diligent and catch yourself. So, 2.2, 1.47, 2.19. I got to figure out which one is the biggest and then which one is the smallest. So, obviously, I can tell 1.47, that's the smallest. That's going to be my third one that I write. 2.2, 2.19. Which one is the biggest? 2.2. So, I'm going to go 2.2, comma, 2.19, comma, 1.47. That is from greatest to least. Okay, 5.6, 6.3, 6.35. Again, greatest to least. I can tell which one is the least.
Yeah.
It's the only one that has a lower number. 5.6 is going to be my last number. Now it's between 6.3 and 6.35. Well, 6.3 is technically 6.30. So which one is the biggest? 6.35 and then 6.3. Don't let those get you. They are sneaky. All right, next bit. Oh, look. Really challenging. Money. Guys, seriously. It wants you to write the amount with a dollar sign. So $3.04 is $3.04. $1, 5 times 6 pennies is $1.56. $9, 6 times, that is $9.60. $4, 9 pennies.
$4.09.
$7, 3 dimes, 2 pennies.
$7.32.
8 dimes and 1 penny.
$80.
Ha 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 ha, tricking you. 81 cents. And then the last bit, this is when it was asking you to kind of use your finger to measure to help find the distance. So it says, look in the walking path below. Will begins at the starting point and walks 0.6 miles. Where on the path would he end his walk? Well, 0.3 would be half of 0.6, right? So if I just sort of measure like that, that would be about where 0.6 is, because it is half the amount. An architect has marked a distance of 6 inches or 1/2 foot on the wall. She wants to make another mark that shows a distance of 3 feet. 3 feet is going to have how many half inches in it? 6. Where will she make a mark on the wall? How do you determine this location? Okay, so if I'm given a half here, and I can see that there are 1, 2, 3, 4 lines in between. Okay, so here's a half. 1, 2, 3, 4. Here is 1. 1, 2, 3, 4. Here is 1.5. 1, 2, 3, 4. Here is 2. 1, 2, 3, 4. Here is 2.5. 1, 2, 3, 4. There's 3. Ta-da! So use what is given, and you can take your fingers and measure. You can count the little dots to measure. But this is one where it's not necessarily asking you to multiply or divide. You're just having to look at what clues they've given you to solve it. Okay? All right.